Hello, my name is Jeff Widgren, a Senior Systems Engineer at Tintri, and I'm here to share with you today some of the incredible value points that Tintri offers, especially in a Citrix environment. I'd like to begin by showing you the general interface of the Tintri dashboard. The Tintri dashboard is really summed up and thinned down, and what's missing. Let's talk about quickly what's missing, and that is the traditional storage concepts as we know it. No LUNs, no volumes, no need to actively manage RAID, but what you end up with is a console of the objects in which you care about the most, and that is your virtual machines, your virtual desktops, and so forth. With that, we'd like to look at the health of the system across the VM store or the whole array, the total I/O push, and always 7 days of trended data in the throughput. But what's especially useful is, and what's missing in today's storage platforms, is meaningful visibility. And what I mean by meaningful visibility is when there's latency and the IT team is challenged with identifying where that latency actually lives, we have end-to-end visibility offered to you simply by mousing over that latency, and we break that apart by the host layer, the network layer, and in fact the storage layer as well. I refer to this as your invitation list. Don't invite the storage guys, don't invite the network guys. This might be a host issue in particular. We'll dig down a little deeper here into a virtual machine that's experiencing latency as well. And when you have this particular VM, the name of the VM, experiencing latency, the challenge is on. At 32.2 milliseconds latency, a simple quick mouse over will quickly determine that this certainly is not a network issue or a storage issue, that this is almost solely focused on the host itself, saving the operations team a ton of time to be able to get to resolution. I'm going to take the presence of latency and expand that out to an actual timeline so that we can begin or continue our investigative work, taking that out to the full 7 days of metrics to see if there's a beginning and an end to be able to further troubleshoot. We don't see that in this example, but I can also take a peek into the virtual machine itself, and that is take the latency up top and then peer into the CPU and memory of that virtual machine at the bottom to gather an idea very quickly. Is this a runaway process and or possibly even a memory contention issue? And if we take a look at the legend, the yellow line is quite stable. It wouldn't be a runaway process to me, but in fact a lot of swapping going on in this particular machine. I'd like to quickly go over to an incredibly unique feature when it comes to unique control over our virtual machines. And that is, I'm going to sort the IOPS column to gain the visibility of a fairly busy machine on our system. With that, we'll take a look at the I/O, which is kind of, you'll see this example, it's a flat line, which is an unusual looking workload, but I want to take this particular workload and put a ceiling of serviceability on it, if you will. And that is, you can see this maximum level here of I/O. Just under 10,000 I/O is what will be allowed to this system. If I simply drag and drop this down to and lower that ceiling of serviceability down to 5,000 I/O, here in just a few seconds you'll see how quickly our workload instantly adapts to that new ceiling. And with that, it really answers some really important questions in the VDI space. In the VDI space, we never know what that user is going to be doing next, what link they're going to click on, what video they're going to launch, what kind of burden they're going to put on the system. Tintri does an incredible job of providing auto QoS, and what you're seeing here is as an example is manual QoS on a single and specific workload as well. We refer to boot storms in the VDI space as a trivial task. The primary reason that we can say that is that the every individual workload on a Tintri is isolated from one another. Their I/O is separated from their neighbors, therefore protecting the workloads from their neighbors and protecting their neighbors from their particular workload. So it's now in the past. It can't happen on a Tintri that you have a runaway virtual machine that's causing problems to all the other neighbors on the system as well. So that wraps up today's demonstrations from Tintri. From quality of service in an automated fashion, out-of-the-box behavior, manual QoS for those exception workloads that you want to either guarantee a floor of serviceability or even a ceiling of serviceability, as well as knowing that the natural behavior of Tintri, even in the VDI world, is to protect every workload from one another. Therefore, having a runaway workload negatively impact neighbors is an absolute thing of the past. Thank you.